Welcome to another lesson of Sun Classroom. Topic is sets, and the objective is define finite and infinite set, null set and universal set, as well as subset. This is what we want to look at for this lesson. And most of this you already know already, so we're not going to spend a great deal of time explaining these. But let's look at the definition for finite and infinite set. A finite set is the possible to a finite set. It is possible to count all the members of the set, but an infinite set, it is not possible to count all the members. And some examples are all the number possible you can count. So you can count from 1 to infinity. In other words, our number system is so complex that you can count and reach the last possible number, because number continue all the way to infinity, to billions, trillions. You can count up to trillions and beyond that. Okay, so these are all the numbers in our number system gone up to multi-billions, multi-trillions, and beyond that. So that's a set. Okay, and there are other infinite sets as we look at before, but a finite set is a set that you can count all the members. For example, all the letters in the alphabet. These are an example of a finite set, A, B, C, all the way to Z. So that's 26 letters, all the letters of the alphabet. So an example would be for infinite set. Let's write that. Infinite set all the number in the base, I just in the number system. Okay, so that would be 1, 2, 3. Again, I give 3 dots to say that it continues. Alright, so a finite set. A finite set finite set is, the letters of the alphabet. Letters of the alphabet. Okay, that's a finite set. Alright, so those are 2 examples, letters of the alphabet. Okay, so we have 2 examples, and we know this already, so it's really a revision. So another set that we must talk about is what we call the null set or the empty set. The null set or the empty set contain no element, and it is denoted by the symbol below. So if when you see this symbol, two brackets with nothing inside it, that is the null set or the empty set, or this symbol as 0 with a cross around it as the empty set. Okay, and that's not no introduction. We'll look expound on that when we're talking about set subset, and maybe we can do a little part of it now. The empty set is a member of all set. Okay, okay, so that's basically it. The empty set and that's what it is. Okay, so the universal set. The universal set, for any practical problem, the universal set is the set from which all the elements are taken. The universal set is denoted by the symbol U. So the universal set, when we talk about letters again, we go back to the alphabet. The universal set U is equal to the letters of the alphabet. Okay, so the universal, so all words are made up of letters, and all letters came from the alphabet. So literally all word is a subset of the universal set, the alphabet. Okay, so the universal set would be the letters of the alphabet. Okay, that would be letters, and the other universal set like but this one is infinite. All possible numbers is a universal set. Okay, that's real numbers. We look at that one when we were talking about numbers. Real numbers is a universal set. But we said R is equal to U. So some of these are revision, but we are looking at them in general now. So when you talk about the letters of the alphabet is a universal set. Okay, so now it's the next one is subset. Okay, and let's look about what subsets are. If A and B are any two sets, and all the elements of A are contained in B, then we say that A is a subset of B. We write it like this: A subset B. These are nothing new, but just to go back through them so you may understand what we're talking about when we talk about subset. So let's look at a more general application of it. Okay. Okay, so if I have the set A, and we're talking about subset here. If I have the set A as element 1, 3, 6, and 8. And the set B, is equal to, is equal to 1, 3, and 8. then if you look at this set, 1, 3, and 8, you can find 1, 3, and 8 in the set A. So therefore, we are saying that B is a subset of A. So that would write like this: B is a subset of A. In other words, subset means it is taken out of A, or all the elements of B can be found in A. That is basically what we are saying for that one. Okay. So now what we want to look at is what we call this here, the number of subsets. Okay, the number of subsets. The number of subsets. Alright. So if I have the set A, which is equal to A, B, and C, A, B, and C, and that we are looking at subset. How many subsets can we get from the set? The set A, which is A, B, C. Okay? And what you need to know that every element in the set is a subset of the set. So the set A is a subset of the set. The set B is a subset of the set. And the set C is a subset of the set. Okay? So also, each member pair is a subset of the set. So A, B, is a subset of the set. And also AC is a subset of the set. And also BC is a subset of the set. BC is a subset of the set. Okay, BC is a subset of the set. And what you need to know as well, that the empty set is a member, any set, the empty set is also a member of the set. So the null set is a member of all sets. Is a subset, sorry, when I said member, I meant subset. The empty set is a subset of all sets. So every possible set, the empty set is a subset. And also, the set itself is a subset of the set. So that will be A, B, and C is also a subset of the set. So how many sets do we have? When we exploit all the possible sets, we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 set numbers of subset can come from the set ABC. Okay? And this is the practical way of doing it. Exploit each member, make sure each member paired in 2 and then paired in 3. Depends if it's 4 number, you get another great deal of about 5 more sets added to this. But you can also, there's a formula you use to work out this if you don't want to pair them like this. And the formula says, the formula is S, which is subset, equal to 2 upon N. And N is the number of elements you find in the set here. So if you look physically, you see 3, remember 1, 2, 3. So 3 members here is the number N. So this would equal to 2 to the 3. 2 to the 3 power. We look at powers already, we know how to work out powers. 2 to the 3 powers. 2 to the 3 powers. And that is 2 times 2 times 2 times 2 times 2. Okay? So 2 multiplied by itself 3 times. So that will be 2 2 is 4, 2 4 is 8. So the answer is 8. And when you do it practically, you see that this 8 subset you get 1, 2, 3, 4, 5, 6, 7, 8. So 8 subset, and if we do it by calculation, we'll get 8. So we can use either method to work it out, but sometimes it depends on how much members in the set to work out all the subset out of your head by listing them would take a long time, and it can be very long and very long. So if you have say like 5 members in the set, that's a couple thousand subset you will get out of it. So you best use the calculation. Okay? You best to use the calculation to work out that one. Yes. So let us, okay, this basically what we want to look at for this lesson. So thanks for watching this video. Please remember to subscribe to the page to get new videos, as well as give it a thumbs up if you like this video.